Hi everyone, Alex here, Techtastic. This is my first video on this new channel. Today we're going to be talking about how to gain some easy science points with a fairly basic craft, nothing really advanced going on in the parts category. It should be pretty cheap too. In the case of this game, this is Scientific Sandbox. As you see, I don't have a money bar up there. I will be using, while this is a modded installation, we're not going to really be using any of that, but I only have a few of the beginning scientific nodes, and only going up to advanced rocketry, not heavy rocketry. You will need to have these same nodes to build what I'm building, but it should be really, really easy. I've already done this, so I have some science already, but I went ahead and pre-built this ship. Very, very, very easy. You can replace these SRBs I'm using down here, which are, let's see, yeah, these are from the Space Y expansion. You could use the Thumper solid fuel boosters if you so choose, but the important thing to remember here is aerodynamics to start too, because you're not really using any big stuff. If you look at my profile from the top, I'm not really making much of a hole. It's just pretty much straight through. Even in the shadow you can see the shape is, for the most part, there's not much drag, relatively speaking. So, let's see. I have a single science module, the Science Junior, and I'm actually going to add a press map barometer. I'm going to do these a little bit higher up so they're out of the way. And let's see, I'm also going to add a thermometer. And for good measure, while we're at it, I will add not one, but we'll be adding 2 mystery goo containments as well, just for that little extra bit there. And those are pretty close to even. I'm a little bit of a stickler with that stuff, but yeah, this one's going to come down just a touch. About there. Yeah, that'll work. This is going to be a manned mission. Also critical here, you'll see I have Delta V statistics open because I have MechJeb installed. MechJeb is very valuable for attitude and automation. And it also takes care of staging and some other stuff which we'll cover later on. But for this video, this is just a really basic ascent platform. We're gonna use a little bit of the MechJeb functions, mostly to set our trajectories in a very primitive way. Ideally, we're going to shoot for a gravity assist for a free return trajectory when we go back up, or when we go up the first time to the moon. It should be pretty easy overall. We're going to have just enough delta V here to get us where we need to go, and just enough to return. There'll probably be a 2% remainder when we come back, and we'll just burn that off when we re-enter, since we're going to be coming back in around 2,900 meters per second or so. This should be pretty easy. The one thing that's trouble that a lot of beginners run into is managing your maximum dynamic pressure on takeoff, and we're going to see that when we start getting up to some seriously high speeds and Gs. Just when we're in the middle of the stratosphere, maybe a little bit beyond, but without the later versions of MechJeb, we don't have a way to control that manually. We have to kind of just do it by feel. So we're going to do that now and see how it goes. Okay, let's see here. Let me double check. I also have this nose cone staged as well. And we're going to go ahead and let's see. We'll fire that off right there. That'll do just fine. These are more than enough to get us where we need to go. And we're going to keep all of these in the same stage so I can show you guys what I'm talking about with maximum dynamic pressure. very important. It's also called max Q. That's the official term for it. And we need to get to an orbital velocity of around 2,800, I believe. I think that's what it is. It's damn close to that, but because Kerbin is a 110 scale model, sort of. There's a few things that aren't right about that, but it's a 1 to 10 scale model of Earth, and the orbital velocity for the planet Earth is 28,080 kilometers per hour. So that's roughly, yeah, I mean, it's fast. That's roughly 17,450 miles an hour or so. In this case, we're also not going to really be worried about using any spin stabilization with this. I'm going to roll it over 180 degrees because that's my personal preference, but we're going to go do that right now. So it's dark. I didn't really plan this launch, so we'll see how the timing works. We're going to shoot for a periapsis of approximately 90,000 and an apoapsis of around 120,000 or so, maybe 130 or 40. We'll see. It's not really that critical for this purpose. Also, I do not have any RCS thrusters on this. This is all done with reaction wheels. So these rockets do have gimbaling on them, so they will be my primary stabilization. So I have my MechJeb open here to make this easy so I don't have to do it manually. I'm going to select a surface orientation for these commands, and I'm going to set this to 80 degrees because I'm estimating best as possible. We're actually going to go to 180 out on this. Best as possible to reduce my maximum dynamic pressure. The problem is if you launch at nearly straight up the whole way up, you're not going to have a ton of you're going to need a lot of delta V to get into orbit, so that's a serious issue. If you turn too early in the atmosphere, you're going to have a really high amount of dynamic pressure, and it's going to burn up. It's going to be really rough. So I'm set right now. Let's see, this is a manned pod. I have Jeb Kerman in there right now, and we're going to go ahead and get this started. And you'll be able to see when our aerodynamic forces reach their extreme here. Right about here is where it's getting pretty high. We're accelerating very rapidly. Okay, we had primary engine burnout here. Burnout, flame out, whatever you want to call it. I'm going to let this hang for a second here before I light her up. Okay, 2 SRBs off, main SRB off, and we're going to change our attitude to 0 in this case. And as soon, very exciting, I know. Can't really see what's going on here. And okay, we will go ahead, and I need to actually change the stage really quick. Okay, so I do not want to fire that nose cone off right now. Switch to our map view, and we'll be able to see. Okay, now that we're in orbit, we want to reduce our pitch angle close to atmosphere, close to be pointing at atmosphere, which is difficult to see. Just at the atmosphere above the horizon. That should be pretty effective at flattening out our trajectory. This is going to end up a little bit higher than I originally wanted. So the more you have to turn in here, the less efficient it's going to be as well. And you can see how fast my thrust to weight ratio is climbing right here. This is not a lot of fuel on this thing. And I don't really want to turn it in anymore. So here's what we'll do. I'm going to kill the engine for now. And really quickly, Let's see. Let me find it in the dark here. Okay, we're going to activate and decouple. We don't need that nose cone anymore. And we're going to switch to orbital control, and we're going to switch to a prograde orientation. So prograde means we're facing the same direction of our present velocity. And we're going to warp just before our apoapsis here. Really simple. And then we're going to fire our engine again, and we're going to wait for our periapsis to show up on our patch here. Okay, so we have 39,000. Move that a little bit so I can see. And we're just doing a nice, slow, easy burn here. Now we're out of the atmosphere. We'll be clear. There won't be any drag. Or we'll stop a little early. We'll stop it at 80 kilometers. And we're going to go ahead and set our target. Okay, let's take a look at our nodes. So we have an ascending node and a descending node. A descending node is when the craft is moving over, both nodes actually, when the craft moves over the equatorial section of the primary, which is Kerbin's primary in this case, and this is the angle that it goes from. In this case, descending node is north to south. So this descending node is minus 0.2 degrees. That means that we are coming in where the equator would be 0 degrees, the meridian, whatever you would call it, the north-south meridian, would be 90 degrees. This would be, our orbit is minus 2 degrees here. So, minus 0.2 degrees. So we're coming in minus 0.2 in this direction. The ascending node is the exact trigonomic opposite, where you would be going up instead. So we're actually coming up here positive. Our pitch is 0.2 degrees. Same thing. Those two are always going to be the opposite, radian opposites, whatever you call it. That's not important. We're within a fifth of a degree for this. It's totally fine. So what we are going to do is, I'm not going to time this, and I'm not going to use a resonant orbit, so we'll just skip time until I make contact there for the sake of keeping this video short. We're going to warp to our periapsis, and we're still staying prograde. If anybody's not using MechJeb, you can just use the SAS functions with a pilot, and it works out just fine for the most part. There's a few things that are a pain with the stock system. I greatly prefer MechJeb. Also because this can be used without a pilot. You just put the module on. It's stuffed inside a part. I kind of hid it a little bit. Okay, now we are in prograde right here. At periapsis, your thrusters are the most efficient. It's very critical to do this burn at a periapsis. We're going to have just enough. We're just going to fly right past, just bounce the satellite a little bit, and come right back, hopefully. And I went a little bit far there, so I'm going to switch retrograde, and as we don't want to, we want to find ourselves in a free return trajectory where technically that's going to come right back in, but that's also going to be a pretty violent re-entry too. So here, let me slow this down a little bit. We should be able to get pretty close here. That's about all she wrote as far as how close I can get with how much fuel I have left. 100 meters per second is not that much. We should, I'll try a little bit more, because this is going to be very inefficient coming back. Okay, that's close. I can deal with that. All right, so now that we're set up there, I'll leave it in retrograde orientation, and we will warp out to our moon encounter. Okay, now we see our relative orbital pattern with the moon. Now, we're not really going to be doing anything fancy here. Sometimes when you get out of the crafts with just a stock system on an EVA, the whole craft moves a little bit, like right there it did. But because I have MechJeb on here, it keeps the craft stabilized where I told it to, with or without anyone being on board. So do a quick EVA report. That's fine. Oh, I also have some automatic science mod on here that I was trying out. It just does the stuff automatically at a certain time. It's not really a big deal. So I'll do some manual stuff here, but I've already done all this, so do your science, and then we can actually see on here where we're going to come out of the gravitational influence of the new primary body here, and that's going to be right about yay. So we'll just warp out of that influence, and you can see what's going on here, how I'm just barely within the gravitational influence of this very, very small moon. I suppose it's not that small, relatively speaking. Okay, now here's an important part. Since we only have 105 meters per second of delta V remaining, we're going to have to re-enter on one pass here, most likely. I will reduce this as much as I can. We're going to target to come in around, let's see, I could probably do as low as 35,000, but if I get any lower than that, it's going to be a damn near a ballistic reentry, and it's going to be hard for all of my science stuff to survive that. So we're going to shoot for a slightly more conservative reentry around 40 or so would be good. Anything above that is going to be too slow. The aero braking effects will not be high enough, and you'll stay in a loop for a few turns, and your ablator and your heat shield will be gone. So we're definitely going to try to re-enter on this one. Okay, that was a little bit much. You know what? Let's see what happens. Let's try it. Let's give it a shot at 37,000, and I'm going to also burn the rest of my last 43 meters per second off of delta V right before we re-enter. So we'll go ahead and warp to nearby re-entry. I also have I don't have it turned on right now, but there's a hyperwarp plugin too. I forgot the exact name of it. It might be called hyperwarp. Regardless, it's an excellent tool to have. For example, if I cancel my warp here and I pull this down, let's see, set to hyperwarp. Okay, that's just a different set of warp scaling. It's absolutely wonderful when you start getting out to the big stuff. This is also modded with more planets. This is Joule, the original orbit of Joule. They have Sarnus, Urium, Neldon, all their dumbass names. Plock. Elo is actually a satellite of Joule or Sarnus now. It's interesting. It's a great set of mods though. This extra planets mod or something or other. But I changed my warp characteristics, and now I will warp to right here. Should be significantly quicker with the scaling. And that's close enough for me. We're going to go back to retrograde position. I didn't use the observation on this. I actually haven't done it right here, so while I was out there, but you should have used this. They're out there. Okay, now we're at a definite re-entry point. We're gonna try. See, ideally you want to shoot for about 5 to 7 degrees coming in, so you don't overheat too severely. Okay, that's good, and we will go ahead and decouple. Now we're going to keep this on retrograde here. We can set it to surface velocity minus. It's approximately the same. It's not, mathematically it's not the same, but it's very close. And we'll check our parameters for, yeah, I never turn these up. I'm not sure if I had a mod version or a modded version before where I was able to set my parachutes to only deploy when it's safe, regardless of pressure and altitude settings, which is very, very useful because if you set these too low, they're going to open when you're going way too fast, and it's just not good news. But we're going to go ahead and arm shoots now, and we will speed it up a little bit there. Okay, and once we start dragging here, I'm going to hold my ablator open so we can see how much it gets eaten up. We're coming in a little steeper than I wanted to, but it's going to turn down a little bit when we start aero braking. We're going to be coming in probably just a fraction below 10 degrees once we hit our actual periapsis. And let's see here. This craft is probably going to try to tumble a little bit when we start getting into some serious drag. Yeah, we're actually going pretty fast. 31,000. That's a cooker. You can do all of this stuff manually wherever, but the whole point of this is a simple craft with very few things unlocked to gain. That's about 225 to 250 science the first time around when you do it. It's not a bad deal at all. And we are still at 36,000 feet. We're 35,000 meters right now, and we are still struggling to slow down. Hopefully it's enough aero braking to keep us from skipping back out. I'm pretty sure it definitely is now. But when you come in at a shallow angle like this, it's very, very mild G-force, but you're going through an absolute ton of very non-dense air, a lot of particles moving at high rates of speed. Let's see here. So yeah, it's taking quite a while to slow down, but that's not a bad thing. When we start getting down near stratosphere is where it starts getting ugly. But that's the thing, if you come in at too steep of an angle, you'll get yourself in a bad position, which is a hell of a lot of G-force, and you're going to overheat almost everything, even with the heat shield. The steeper you come into the atmosphere, the more difficult it is to maintain everything in one piece. But come into this nice shallow angle here, see I'm coming in about 7 degrees now. Is perfect. There's almost no G-force until I start getting down into stratosphere, where we start really aero braking really fast. But this re-entry right here is, well, I don't know if I could say textbook, but it's damn close. And we're going at a reasonable rate of speed now before we even hit the top of stratosphere. And yeah, we're fine now. Go ahead and turn my stabilization off and let the craft do what it wants to do. I've already armed my chutes, so I will go ahead and skip to 4x, full physics warp. I guess I did not arm my chutes. Whoops. But I have a single drogue in here just in case something happens. It's survivable. We can go ahead and jettison heat shield too. Shave the extra weight off. I didn't reduce the ablator count on this. I just used the stock amount. I mean, you save weight when you reduce the ablator mass, but you never know if you're going to need it if you miss your textbook reentry, and either your textbook or your planned reentry. If you need a lot of ablator and you don't have it, well, surprise, you don't have much protection then. So we can go ahead and 4x warp this down. And if you want to, if you are using MechJib, you can set your stabilization up if you don't want your stuff flopping around and this and that, but it's really In most cases, it's non-consequential. And we're going to go ahead and cut this drogue. We do not need it anymore. Definitely put MechJeb on your installation. You'll have a good time with it. Yep, this is the exciting part. This wonderful green line. That's been present in every version I've had. I'm not sure what causes it, but just like that. We'll recover, and let's see how much. I mean, I've already done this trip a few times, and it was only 42 science, but generally this trip is approximately, I want to say close to, 225 to 250 in that range. But there you have it, super simple. If you enjoyed this video, if it was useful to you, please like and subscribe. Comments in the section below would be appreciated. Keep it clean and friendly. But I will be back with more later on. Thanks.